Hey there, science enthusiasts! Welcome back to another exciting journey through the cosmos. Ever wondered why planets are round? It's a question that has fascinated scientists and curious minds alike for centuries. Well, you're about to find out. Get ready to have your mind blown as we unravel this cosmic mystery. Let's dive straight into the cosmic mystery and uncover the surprising reason behind it. The universe is full of wonders, and the shape of planets is one of its most intriguing aspects. First off, the main player in this celestial game is gravity. Gravity is the force that attracts objects towards one another, and it's the reason why we stay grounded on Earth. Picture gravity as an invisible hand that pulls everything towards the center of a planet. This force is what gives planets their round shape. Imagine trying to mold a ball of clay with your hands, pressing it from all sides. The pressure you apply from all directions causes the clay to form a sphere. What shape does it take? Exactly, a sphere. This is similar to how gravity works on a planetary scale. Gravity acts in a similar way, causing planets to form a round shape. Over millions of years, gravity pulls matter together, smoothing out any irregularities. But wait, there's more to it. The story of planetary shapes doesn't end with gravity alone. If you think planets are perfect spheres, think again. They are actually roughly spherical. Curious why? Let's break it down. They are actually roughly spherical. Curious why? Let's break it down. The shape of a planet is influenced by more than just gravity. Number 2, let's talk about spinning. Planets spin on their axes, much like a spinning top. This rotation has a significant impact on their shape. Planets spin on their axes, much like a spinning top. This spinning motion creates a force that affects the planet's shape. Have you ever seen a top wobble and bulge out a bit in the middle? That's due to centrifugal force, and it works the same way on planets. That's due to centrifugal force, and it works the same way on planets. As a planet spins, centrifugal force pushes things outward at the equator. When a planet spins, centrifugal force pushes things outward at the equator. This force counteracts gravity, causing the planet to bulge slightly at the equator. This causes an equatorial bulge. The faster a planet spins, the more pronounced this bulge becomes. Because of this, the equator becomes farther from the center than the poles. This is why planets are not perfect spheres but are instead oblate spheroids. Think of it like a slightly squished ball. The combination of gravity and centrifugal force shapes planets into their familiar forms. Now let's add a twist to this cosmic tale. The universe is full of surprises, and not all celestial bodies follow the same rules. Did you know that not all celestial bodies are round? For instance, asteroids and comets can have all sorts of wacky shapes. These smaller bodies don't have enough gravity to pull themselves into a spherical shape. Why? They're too small for gravity to mold them into a sphere. Here's another mindbender. The size and mass of a celestial body determine its shape. What about the largest planet in our solar system, Jupiter? Its massive size and rapid rotation create a noticeable equatorial bulge. Its spin is so fast that the equatorial bulge is even more pronounced. Fascinating, right? So, to recap, the interplay of gravity and rotation shapes planets in unique ways. Planets are round mainly due to gravity pulling everything toward the center. This force ensures that matter is evenly distributed around the core, but they're not perfect spheres, thanks to centrifugal force from their spin. This force causes planets to bulge at the equator and flatten at the poles. It's a delicate balance between gravity and rotation that gives planets their roughly spherical shape. This balance is what makes each planet unique. Before we wrap up, here's a question to ponder. If planets can have equatorial bulges, could there be a point where they spin so fast they break apart? Something to think about. If planets can have equatorial bulges, could there be a point where they spin so fast they break apart? Something to think about. The forces at play in the universe are truly mind-boggling. Don't forget to like, subscribe, and hit that notification bell for more mind-blowing science facts. Thanks for watching. Stay curious and keep exploring the wonders of the universe with us.